What we're looking at today is two things specifically: simplifying rational expressions and multiplication. A rational expression is a fraction whose numerator and denominator are non-zero polynomials. The denominator of a rational expression excludes values that make the denominator 0. I'll provide a pen. 0. Because we cannot divide by 0. And a rational expression is considered in simplest form when the greatest common factor between the numerator and denominator is no more than plus or minus 1. We cannot have any common factors in the numerator and denominator, because if we do, we need to simplify them out. Because that's also the same reason why we can't leave a fraction as 7/14, because it would reduce to 1/2. We need to reduce it all the way down because it leaves it in proper form and it's also easier to work with. So, simplifying rational expressions. A, B, and C can be expressed with expressions with B not equal to 0 and C not equal to 0, such that AC divided by BC is equal to A divided by B, because anything that's in common on top and bottom will be simplified out. We can do the same thing with numbers. 15 over 65 have a common factor of 5, which simplifies out to leave us with 3/13. We can do the same thing with polynomial expressions. Since x plus 3 is in common on top and bottom, we can factor it out, simplify it out, leaving us with 4 over x plus 3. Any questions on this here? So let's look at this first one here. Simplify the rational expression if possible. What is in common on top and bottom? Almost. Now the x plus 2 here is one whole term, yes? So the 2 is stuck with the x. Now do we have an x plus 2 on top? No, so we can't simplify it out. Do we have any other numbers on bottom being multiplied out front? No, so we can't simplify anything with the 4, and there's no x on bottom or top. So this is, it is simplified. We don't have to do anything to it because it is already simplified. It's already in simplest form. Now let's look at this one here. Yes. Because there is an x plus 1 in common on top and bottom, we can simplify it out. And again, when we're simplifying, we're focusing on the factors, these being multiplied together. Because really what we can say that this is that we have x plus 1 over x plus 1 times over x plus 3. Because when we multiply fractions, we multiply straight across. And while x plus 1 over x plus 1 is simplified to 1, just leaving us with 2 over plus 3. Any questions on this here? Okay. Let's look at this one here, simplifying this. Now we can't just simplify the x squareds out, because the numerator is x squared minus 4x minus 12, and the denominator is x squared minus 4. Whenever we have addition, subtraction, we can't just simplify with it there. We have to change it to multiplication. Because if we have things multiplied on top and multiplied on bottom, then we can start simplifying by crossing things out. And it's really identifying what we just did a minute ago. Because with the multiplication, we can split those over to the side, and they'll simplify to 1. So what that means for us here is that, well, guess what we're going to have to do with the top and bottom? We have to factor it. Now, looking at these two here, which ones do y'all find it would be easier to simplify or factor first? The x squared minus 4, because that is a difference of perfect squares, which would factor down to what? X plus 2 and x minus 2. The order in which we put them doesn't matter, so we could have done x minus 2 times x plus 2. Either one would work just fine. Now we also need to factor x squared minus 4x plus 12, or minus 12. So, two sets of parentheses, because as we look at both of these here, there is not a greatest common factor that we can pull out. Since the 12 is negative, our signs are opposite, plus and minus. Now we need to find the factors of x squared and 12. Well, x squared would be x and x. Now the factors of 12 are 1 and 12. 3 and 4. Looking at these factors, 2 and 6. There's more than one reason I'm picking 2 and 6. Because we want this to simplify, yes? So one of these two top sets of parentheses, I need to be what? Either x plus 2 or x minus 2, so that we have something in common on top and bottom. So I would be picking 2 and 6, so that I do get an x plus 2 or an x minus 2. Now, do we want the 2 here to be positive or negative? Positive. Now, off to the side, we can check it to make sure we did multiply this correctly. X times negative 6 would be negative 6x. 2 times x would be plus 2x, which does give us a negative 4x. Now, at this point here, we can cancel out our like terms, which would be our and x plus 2, leaving us with over and this would be it here. Now, at this point, it doesn't talk about restrictions because we aren't too concerned about it yet. But really, our restrictions, let me get a highlighter, would be any values of x that would make the denominator 0, or make us have a division of 0. Well, if we were to talk about it here, x cannot be, well, what would make x minus 2 be 0? We would add 2 to both sides and tell us that x, so if x is 2, it would make that part of the denominator. And since we're multiplying them together, the whole thing would become, so x cannot be 2. Well, what about with our x plus 2? It can't be negative 2. Because if x is 2 or negative 2, the denominator would become 0, and we can't divide by 0. So if we're talking about the restrictions for this here, x cannot be 2 or negative 2. Even though the positive 2 does simplify out, we really want to keep that restriction there. Any questions on this here? Let's look at the next one here. Which one do we want to factor first, the top or the bottom? The bottom, we have x squared minus 9. Well, that's a difference of perfect squares again. So we'll have x plus and x minus 2. And that kind of gives us a hint at what we're looking for on top. Now in the numerator, we have x squared minus x minus 12. Well, the subtraction of 12 tells me that the signs are opposite. One's going to be positive and one's going to be negative. Now the factors of x squared are going to be x and x. Well, our factors of 12 are 1 and 12, 2 and 6, or 3 and 4. Which one do we want to use? 3 and 4. Because again, we want it to either be one of the ones on top to be x plus 3 or x minus 3. Would the 3 be positive or negative? Positive. And if we check this here, x times negative 4 would be negative 4x. 3 times x is going to be plus 3x, which does give us a middle term of negative x, which we wanted. So that is the correct set of factors. And if we cancel out the like terms on top and bottom, it would be x plus 3 and x plus 3, leaving us with over. And again, if we did the restrictions, x cannot be negative 3 or positive 3, because if it is negative 3, the x plus 3 would become 0. And if it is positive 3, the x minus 3 would be 0. And that really doesn't come into a huge importance till we start trying to solve, because these restrictions help us find the extraneous solutions. Let's look at this one here. X plus 4 divided by x squared minus 16. Can we factor the x plus 4? No. There is no greatest common factor between these two terms, and since the degree of x plus 4 is 1, it's already simplified. Now, x squared minus 16 will factor. And what will it be? X plus 4 and x minus 4. And we get this because x squared minus 16 is the difference of perfect squares. And now we can simplify what's in common on top and bottom. So the x plus 4 is one whole term. Because whenever we have something added or subtracted, it's going to be considered one whole term. Now we can see that there is an x plus 4 on top and bottom, so this x plus 4 and this x plus 4 will cancel out, leaving us with x minus 4 on bottom. What do we have on top? 1. Because whenever we have something on top and bottom, because the x plus 4 divided by x plus 4 is 1. Whenever something factors out completely, we're left with 1. The only way that we can get to 0 is if we are adding or subtracting two like things. So this here would be our answer. And if we wanted to look at restrictions, x cannot be, well, positive or negative 4. Are you ready for the next one? So we're looking at this one here, x squared minus 2x minus 3, and x squared minus x minus 6. Now this is the first one here that we have, that the top or bottom numerator or denominator is not a difference of perfect squares, but we can still factor them. Now which one do we want to factor first? The bottom one. So if we look at this here, the third term is negative, so our signs are opposite. One's going to be positive and one's going to be negative. Now the factors of x squared are x and x. And the factors of 6 are 6 or, which one do we want to try first? 2 and 3, which one would be positive? And the 3 would be negative. And if we did check this here, we would get a middle term of negative x, which we wanted. Now we need to find the factors of the numerator. Now looking at this here, since the 3, the third term is negative, our signs would be opposite. One's going to be positive and one's going to be negative. The factors of x squared are x and the factors of 3 are 1 and 3. There's only one set of factors. So what does that mean the sign for 1 is going to be? Positive? Positive. And the 3 would have to be the negative, because the only way that we can have something in common on top and bottom is if one of those is x minus 3. And if we do check this, we would get a negative 2x. So this does work, which means the x minus 3 on top and bottom would cancel, leaving us with x plus 1 over x plus 2. And that's it. Now we can't cancel those x's out because, again, they're attached together. The x plus 1 is connected and the x plus 2 is connected. We can't just cross those out. Any other questions on this here? All right. Multiplying rational expressions. Multiplying rational expressions together. Whenever we multiply rational expressions, we multiply the numerators together and the denominators together. We multiply straight across. And with a lot of these here, it's going to be easier to multiply straight across first and then simplify what's in common. And the denominator still cannot be 0. Now our first one is this one here. We have 8x cubed y divided by 2xy squared times 7x to the 4th y to the 3rd divided by 4y. Now there's different ways we can go about doing this. Because if we look at this here to begin with, both rational expressions do have like terms on top and bottom. Because if we wanted to, we could start out by simplifying first, then multiplying, and then trying to simplify again. Or we can go on and just multiply everything together and simplify that way. So for this first one, why don't we go on and just multiply the two together? So for multiplying on top, well, we would multiply the numbers together, so we would do 8 and 7. Then we multiply our like variable, so x to the 3rd times x to the 4th, and then we would have y times y to the 3rd. We're going to multiply these together. In the denominators, we're also going to have 2 times 4 being multiplied together. X. Well, there's only one x on bottom. There's none others. And we also have y squared times y. Well, we can do 8 times 7, which is 56. X to the 3rd times x to the 4th. 7th. When we're multiplying like bases, we add the exponents. For multiplying like bases, we add the exponents. And y times y to the 3rd would be y to the 4th. The denominator, 2 times 4 is 8. X, because there's only one of them. And y squared times y would be y to the 3rd. Well, we definitely have things in common on top and bottom. Because 56 and 8 do have a common factor of 8. Now, if we want to, especially if these numbers get bigger, in the calculator, we can do 56 over 8. The calculator will simplify that. It won't simplify the variables, but it will simplify that number there. And 56 divided by 8 actually works out to be 7. And it would be on top. It would be on top. Now we need to look at the variables. Whenever we have like bases being divided, so x to the 7th divided by x, we subtract the exponents. When like bases are being divided, we subtract the exponents. Now the exponent on bottom for x is 1. We just don't write it in. So 7 minus 1 is 6. And since the biggest exponent is on top, it's going to stay on top. And for y, we have y to the 4th divided by y to the 3rd. Well, 4 minus 3 is just 1, and it would be on top because the bigger exponent is on top. And this would be it here. And that's our answer. Any questions on this here? Let's look at this one here. So we want to multiply these two together. So the numbers that we're multiplying together on top is going to be 6 times 9. And then we would have x squared times x to the 5th and y times y squared. And then on bottom, we're going to have 3 times 2. Well, we only have an x, and then we have y cubed times 1. Now at this point here, if you feel comfortable with canceling things out, you can go on and cancel things out and simplify down. Because I'm going to use a highlighter here. Well, 3 times 2 is what? I mean, we do have that like term on top and bottom, yes, so I would simplify to 1. I mean, we could also say that one of these x's will take out one of these here. And well, how many y's do we have here? 3, which would really match up with this one here. So if I wanted to, I can cut and dice this, simplifying that way, because it is all multiplication. We don't have any addition or subtraction. And I'll remove the highlight. And I'm going to write this out, and then I'm going to erase it all and then go the way that we did on the previous one. Because what we could say is 3 times 2 is 6. Well, that and that are gone. This 1x will simplify with one of these here, just making that x to the 1st. That 3 and those 3 are gone, telling me that I have 9x to the 6 over y. Because we canceled out the like factors. And we can do this because it's all being multiplied on top, all being multiplied on bottom. Okay. We don't have to do it that way. Because what we could say is 9 times 6 is 54. X squared times x to the 5th is x to the 7th. Y times y squared is y cubed. 3 times 2 is 6. X y cubed times y is y to the fourth. Now we can simplify. We can see what 54 over 6 simplifies to, which actually simplifies to 9. X to the 7th over x, well, we can subtract the exponents. 7 minus 1 is 6. Bigger exponent is on top. Now the last one we have is y to the 3rd over y to the 4th. Well, 3 minus 4 is what? Negative 1. Another way that I look at this here is I subtract the exponents. So I don't always do 3 minus 4. I'll do 4 minus 3, which is 1. Is the exponent bigger on top or bottom? Bottom, so it stays on bottom. Because we could have written it as y to the negative 1 on top, but if the exponent's negative, we have to move it from the numerator to the denominator to make it positive. So we get this here. Any questions on this here? We ready for the next one? All right. I'm going to show you one more way to do this. Do not write this. I don't find this as an effective way to solve these, but I still want to show you guys how to do it anyways. When we look at this first one here, we have 3x to the 5th y squared. 3 is prime. But when we have x to the 5th, it's really telling me that I have x multiplied by itself how many times? 5. So what we can do is say 3 times 1, x, 3, 4, 5 times. And we can also say that we have y squared, so we would have 2 y's. Well, 8 as a prime factorization would be 2 times 2 times 2. Because if we factored it all the way down, it would be 2 times 2 times 2. And we can do the same thing, and here we would have x and y. For the other one, 6 is 2 times 3 if we write it as prime factors, x and y times y. And what we're doing here, and what I'm doing here, is writing these as small as we can get them, as their prime factors. 9 would be 3 times 3, x squared would be x times x times x, and y. Now if we multiply these together, we would put the numbers up front. 2 times 3 times 3, and then we would have 5, 6 x's, 1, 2, 3, 4, 6, and then we'd have y, 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 y. On bottom, well, we'd have 2, 1, 2, 3, and 2 3's being multiplied together. 1, 2, 3, 4 x's and 2 y's. And now what we can do is look at this here. Well, this 2 and this 2 would cancel. This 3 and this 3 would cancel with this 3 and this 3. This x and this x would cancel. This one and this one. This one and this one and this one. And this y would cancel out with this y. This y would cancel out with this y. And on top, well, we don't have any numbers left, but we do have x squared. On bottom, 2 times 2 is, and that's what we have. I don't see this as the most effective way of actually doing this. What I would do is I would look at the numerator. Well, we have 3 times 6, yes? And what is 3 times 6? I'd go on and multiply. We have x to the 5th times x. We have y squared times y squared, which would be y to the And on bottom, 8 times 9 is 22. X times x cubed would be x to the, and y times y is y. Now we can simplify. 18 divided by 72 is 1 over 4. I won't put the 1 in till the very end, because if there are variables up there, we really don't need it, or numbers up there. X to the 6th divided by x to the 4th, x squared, and it's bigger on top, so it'll stay on top. Then we have y to the 4th over y squared. 4 minus 2 is 2, and it's bigger on top. Yes. They both are effective. This one here is just a little bit more so. Any questions on any of this here? Find the product. So we have to find the product, and we cannot have any greatest common factors or any factors on top and bottom. So before we multiply these two together, it will behoove us to factor them. Because if I factor in all of 4 spots and then multiply them together, it's going to be a little bit easier to work with. Why don't we start off with the 3x minus 3x squared? Is there a greatest common factor between these two terms? 3x. So I can factor it out. And if I factor it out, 3x factored out of the 3x would be 1 minus 3x factored out of 3x squared would be x. So when we factor the 3x out, we have 1 minus x. Well, 3x has no other terms with it. That is factored down. Now, which one do we want to factor next? X squared plus 4x minus 5. Because it really doesn't matter which one we factor first. We're going to have to factor both of them anyways. Now, since the 5 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Now, the factors of x squared are x and 5 and 1. Because we want a positive 4x, so we would need the 5 to be positive. And if we check this here, we would get a positive 4x. Now we need to factor the other one, x squared plus x plus 20, or minus 20. Well, the signs are going to be opposite, since 20 is negative. The factors of x squared are x and do we want the 5 to be positive or negative? Positive. And that actually is the correct set of factors. Any questions on this here before we multiply them together? Now we multiply them together, any terms that are not inside the parentheses, so the 3x on top and bottom will move to the front. So here we have 3x times 1 minus x times x plus 5 times x minus 4 over 3x times x plus 5 times x minus 1. So what do we have on common on top and bottom? The x plus 5 and the we do have the 3x and 3x, yes? Is there anything else? Right, the x minus 1 and 1 minus x are very similar to each other, yes? Now, before we do that, I'm going to go on and rewrite this back out. 1 minus x minus 4 over. Now, if we look at the 1 minus x, we do see that it is very similar to x minus 1. It's just the signs for both of them are flipped, yes? What that means we can do is that I can actually factor out a negative 1. Because if I factor a negative 1 out of 1 minus x, the negative x is going to become what? Positive, because I factored the negative away. The positive 1 is going to become negative flipping the signs. So if we have two factors that are similar to each other, but the signs are flipped, and they have to be flipped for both, because on bottom we have a positive x and negative 1. On top, we had a positive 1 and negative x. The signs for both were flipped, so we can factor that negative out, which does make these the same, leaving us with negative x minus 4. Any questions on this here? We'll stop here. We'll pick this up tomorrow.